Now let's have a look. What do we mean by sigma notation? Okay, have a look. What this means is the sum from r equals 1 to 5 of r squared. So what are we going to do? We start with 1, and what are we going to do? We're going to substitute into the general term r squared. Now how does this work? Equals. Okay, start at 1 and substitute in to the r squared. So what does that give us? 1 squared. Now we're going to work with natural numbers. So we're going to go 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Okay, remember you start, that's your start, and then your finish is 5, and you're going to keep substituting into r squared. So what do we have? 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Nothing in it. 1 plus 4 plus 9 plus 16 plus 25. If you work that out, it comes to 55. It really means sigma means sum. Add up the terms starting from 1 to 5, substitute it into there, giving you that. Okay, be careful with those. It can come up quite a bit. Okay, now look at the next one, and I want to develop a bit of a principle here. If you look at this, notice we're not starting at 1. We started 4. Here, we started at 1 and 5, and notice how many terms were there. 1, 2, 3, 4, 5. There were 5 terms. The problem here is, I wonder if we have 9 terms. Now, there's a very, very important principle that I'm going to show you as we develop this. Well, let's just work this out. Let's go for it. Equals. Well, what does it say? It says start at 4 and sub into the little term here. So it's 4, 4 plus 2. 4. Then we're going to go, what comes after 4? So it's 4, 5, 6, 7, 8, and you stop at 9. Start and finish. 4 to 9. And here we go. 5, 5 plus 2 plus 6, 6 plus 2, 7, 7 plus 2 plus 8, 8 plus 2 plus 9, 9 plus 2. So what does this give us? 4 times 6 is 24. Plus, okay, this one works out at 35 plus 48 plus 63 plus 80 plus 9, 11, 99. Okay, if you add that up very simply, that will be 349. Okay, problem is, how many terms are there? Look, 1, 2, 3, 4, 5, 6. There's 6 terms. Okay, there's 6 terms. Now, what I want you to notice is that they're not 9 terms, the thing on top. There's 6. Now, a way to get this, particularly if you're dealing with bigger numbers, watch this. If you take the top number, 9, and you subtract 4, so you say the top minus the bottom, you are going to land up with 5, but we want 6 terms. There's 6 terms in the thing. 1, 2, 3, 4, 5, 6. Check there. 1, 2, 3, 4, 5, 6. So if we've got 9 minus 4 is 5, if I now add 1, I will get 6. So this little rule is very, very critical in finding the number of terms. Top minus bottom plus 1. If you look at the previous example, 5 minus 1 plus 1 is 5. 5 top minus bottom plus 1 is still 5. The trick with this is that if you start at 1, have a look here, there will definitely be 5. 1, 2, 3, 4, 5. But within this case, it's a bit of a problem because you started at 4. So what do? 9 minus 4 plus 1 will give you your number of terms. So you have 6 terms. There we go. Top minus bottom plus 1. All right, people, that's a very important. Top minus bottom plus 1. Remember that for number of terms in a series. This is, by the way, a series is this. When you're adding things, a sequence will have semicolons. But when you put pluses or minuses in, we now talk of a series. Okay, now let's develop this further. Okay, if we look at this example 9, what do you notice? Here we've got a bit of a strange thing going on because we're starting at 3 to 300 and there's no n to substitute into. Oh, this looks like a bit of a pain. Okay, don't panic. Firstly, let's determine how many terms are in this series. Well, the number of terms will be the top minus the bottom plus 1. So what will that give us there? Okay, if you think of it carefully, there's nothing in that one. It's going to be simply, very simple, 298. because obviously 300 minus 3 plus 1 is going to be minus 2. So there's 298 terms. But now my problem is, what do you substitute in? There's no n to stick it into. Now I'm going to cheat a little bit here and to see how this works. Okay, watch this. If you have a look at this, I'm going to rework this as, now maybe this is a little bit naughty and mischievous, but it works like a bomb. You've got 3. You can put n to the power of 0, n to the exponent 0 there. N to the 0 is 1, so you haven't changed much. That's 3 times that. Now watch this. 3 started 3 to the 0, plus 3 times 4 to the 0, plus 3 times 5 to the 0, plus 3 times 6 to the 0. And that goes on all the way till the very final term, 3 times 300 to the 0. And all of these guys are to the 0. So what do we know? That's 3 times 1 is 3. 4 to the 0 is 1. So 1 times 3 is 3. This is 3 plus 3. And it goes all the way down to 3 there. How many terms are there? 298. Now this is the same as saying, well, there's 2. Basically, it's 3 multiplied by 298. There's the 3, if you multiply, look at this, if you had, say, 3 of those, it would be the same as saying 3 times 3. If it's 2 of those 3s, it's 3 multiplied by 2. If there's 6 of them, it's 3 times 6. If there's 298 of them, it's 3 times 298, which is 894. So just remember that carefully. If you don't have an n to substitute in, how does this really work? It's really, really simple. You don't even need to go through what I'm saying. You could have done this. Watch this. You can say this actually equals the number of terms multiplied by that guy, 3. Okay, so what is the number of terms? Is simply 298 times 3. Okay, nothing in that one. Okay, so if you had another one, I'll just show you quickly. If you had something like this, sigma n equals 5 to 100 of 7. Okay, how many terms? Number of terms. What would that be? Top minus bottom plus 1. And then obviously multiplied by 7. And that's very easy to work out. That's 96. Okay, you can actually work that out. 95 plus 1 is 96. Times 7, and that's pretty easy, and you've got then the answer to these things. Be aware of that. Very, very nice thing. Now the next example, guys, is something that's in the syllabus, and it says write a series in sigma notation. Now this can be quite tricky, so I'm going to go through a fairly difficult one, and be aware of this. They might well ask you this in the Matric final exam. Now have a look. You've got an arithmetic series, 3 plus 5 plus 7 going on. It's definitely arithmetic, because what are we doing? We keep adding 2 to each term, and it goes up to the last term, which is 201, and we've got to write this with a sigma in. Okay, well, let's have a look. The way to do it, firstly, what do we know is we want to get the number of terms, because that's important. If you start at 1 at the bottom of the sigma, we can go from 1 up to whatever the number of terms are. So we need to locate the number of terms first, and then we need that general term, that expression after the sigma, this guy, like that. So we need to start from, we could say n equals 1 up to whatever the number of terms are, and we need a general term to do that. So what are we going to do? Let's start by finding the number of terms. Now how do we do that? Well, we need to say, what is that term? Tn, what is its position in the row, in the series? In other words, if we know its n value, we will then know the number of terms in the series. Now it is arithmetic. A is 3, D is 2. Now watch this. So A is equal to 3, D you're definitely adding on 2, and we've got Tn is 201. Okay, so if we use the formula for an arithmetic term, okay, what do we know? We know Tn is 201. The first term is 3 plus n minus 1 multiplied by d. Okay, so what does this give us? 201, bring that across, 201. Okay, we can go, well, let's leave it there in the meantime. It's 3 plus 2n minus 2 if you distribute. So what do we have? 201 is equal to 2n plus 1. If you bring the 1 across, it goes 200 is 2n. And if you divide both sides by 2, n is 100. So this term is term 100. So there must be how many terms then in the series? 100 terms of the arithmetic. So we've got the number on top, provided we start at the bottom of the sigma with 1. Okay, now let's get the general term, the expression that you're going to substitute into that comes after the sigma. Now watch this. Very simply, we've got the 100 terms, so there's 100 terms, which is great. Okay, now let's get the nth term. Tn is a plus n minus 1 multiplied by d, which is 3 plus 2n minus 2, which is 2n plus 1. We actually did it there. Now, what is the significance of this and this? Very simply, you got your number of terms, you've got your general term. So what do we know? We can say, therefore, we've got sigma. It's going to start from, now I'm going to use, let's use a different symbol because we're going to put 2n plus 1 here. So I'm going to maybe say r goes from 1, or let's say n goes from 1. Okay, remember you're dealing with n, so let's keep it n going from 1 all the way to 100. And that is now going to be expressed in what we call sigma notation. Okay, you've expressed it. There's your general term. Now let's verify to see if we're right. Let's see if this actually works. Well, if that is your sigma, well, let's sub in. We'll put 1 into there. 2 times 1 plus 1 plus, okay, 2 times 2 plus 1 plus 2 times 3 plus 1 going on. What does this give us? It gives us 3 plus 5 plus 7 going on. And what would the last term be? Well, think about it. 2 times 100, 200 plus 1 is 201. So this is kind of the reversal of, given the sigma, you now work out the series and then, of course, add it up. But, of course, now we're given the series, write it in sigma notation. Very, very important kind of question. Be aware of that as well. Okay, the worksheet's got some of that in there as well.